In this video, we're going to solve exponential and logarithmic equations. Okay, so there's a couple properties that we'll need. The first property will involve basically the same base, or also called one-to-one property. It's a very basic property, and it makes sense, I hope. For example, in this first example, if I have 5 to the x equal 5 to the 3, well, what do you think x has to equal? X has to be 3. Okay, which kind of makes sense. There's no other value for x that would make that statement true. But if we read the property up here, if a to the x equals a to the y, then x has to be y. And that goes with the logs as well. All right. So basically, if we have the same base, we just equate the exponents. That will be our goal. So for problem number 2, I don't have the same base there, but I'm able to rewrite 27 with base 3. If that's a 26 or a 25, this doesn't work. But because 27 is the same thing as 3 cubed, I can rewrite my problem like that, and now I have two sides of the equation with the same base, and I can equate my exponents, what I just circled there in red. All right, and from here I have a basic linear equation to solve. Negative x equals negative 9, which makes x equal to 9. Remember, we can always check that. I won't do that in this video, but you can always check your answers by plugging in x and making sure you end up with the same thing. Okay, so we can plug in a 9 here and here and see that we should get the same value on both sides of the equation. All right, number 3. Definitely not the same base there, but I can recognize these guys as base 2, hopefully. Right, and it might take a little trial and error, maybe with the help of a calculator, but I should be able to find out that 8 is 2 cubed. So I rewrite 8 as 2 cubed. I still have that exponent. And 32 is 2 to the 5th. And I still have that exponent. Okay, so now remember how I deal with this. That's the product of those two exponents. That's a number raised to a power, all of that raised to a power. So the rules of exponents tell me to multiply those two guys. So I'm going to multiply those together. And now that I have the same base, base 2, I can just equate those two exponents. Right? So it would be 3 times 2x plus 4 equals 5 times x minus 3. Now multiply and solve this basic linear equation. I'm going to subtract 5x from both sides. And then I'll subtract 12. Okay, so those are the easy cases. If I have the same base, then I can just equate the exponent. There is a log equivalent of that, and you can see right here, call this example 1 for my log examples. Pretty straightforward, right? You have the same base, in this case it's base e, the natural log, either side of the equation. So what do? Just drop the logarithms, or really what you're doing is equating what you're taking the log of based on this second property right here. Okay, and then I solve again. This case is a linear equation. So I'm dealing with x minus 3 equals 5, add 3, and I'm done. Now, I mentioned checking your solutions like we can always do in algebra, but for this case, we really want to be careful about that because we have a domain issue with the log function. I could only take the log of a positive value, right? So I cannot take the log of a negative. I cannot take the log of 0. So I always want to check that. I should do the complete check to make sure the 8 is correct. But at least have to make sure that if I plug an 8 into those two spots, I'm taking the log of a positive, which in this case I am. So I'm happy with that value as my answer. We could go a step further to make sure it's correct, but you get 32 minus 3, which is 29, and right here you get 24 plus 5, which is 29, so we know we're right. How about this next one? Same thing. What's the base for number 2? It's base 10, another special base, the common log. So I have the same base on both sides. So basically I drop my log. And I solve this guy. I get x equals negative 14. Okay, so I think that's my answer. So I got to be careful. If I plug that right here, I got a problem. Right? The log of negative 14 minus 3, the common log of negative 17 doesn't make sense. I cannot do that. So this solution that I got isn't really a solution. Right? Because if I plug him back in, I'm taking the log of a negative. So what I would write for this one then would be no solution. There's no solution to that equation.